We'll go on to our next session here, Mirrored Utility Network. Bhoopathi Rapolu, Senior Business Development Manager with Cyient, but you're also a technology strategist, well-known speaker in the industry. Heard you speak about IoT and those, and you're also an author. Your current book, which I'm reading, the Race for Work, actually it's an interesting read. It touches on the impacts of automation, of which all of this digitalization is part of that, on the on workforce. So Bhoopathi, welcome aboard, and looking forward to your presentation. Thank you.
Thank you, Gavin. Good afternoon, good evening, and wherever you are in the world. We're talking about Mirror Utility Network. It's predominantly, the presentations since morning are great. We're talking about various aspects of digital twins, how we enable them. It's pretty much addressing the same problem of the utilities, age-old problems. Now we talked about the problems in terms of aging network, cost intensive for inspection, for the manual boots on the ground approach, and in terms of vastness, the only possibility to effectively manage is digitize it. And because digitalization has solved many problems of scale, and why not in utilities? So when it comes to addressing these problems of nature, the digital twins come in our way, and digital twin at a very minute scale, at a machine level, at a transformer level, at a substation level, or to a circuit level, to the entire network level. Now we're talking about planet level. So the approaches since morning we've been looking at various presentations are really revolutionary, and they're solving problems at grand scale. And one of that approach that Cyient has taken is similar in line for digitalization of the networks, and how we can bring it to the browser, how we can bring the network conditions to what we call democratization. So how anybody in the organization or even at a customer level can access the right data of a timely nature. So that being said, Cyient's approach to 3D virtual network is coupled with the acquisition of this data, followed by applying intelligent processing techniques, both computing as well as analysis techniques, to deliver the right information to the right audience. So digital twins for us, we see that they produced massive results, up to 80% of cost savings, and reducing the time to delivery. So we at Cyient follow various data acquisition methods depending on the need and the specification, be it satellite imagery, aerial imagery, drone-based imagery, or even mobile mapping. We also sometimes use backpack-based solutions, where somebody just ties in a camera and a backpack and just walks around in the inaccessible areas. So that is being that's followed by leveraging the massive cloud computing capability that is available today, and then followed by exploitation or utilization of the data for various business applications. So I would spend a quick scan through of the process, and then I'll jump into the solution that we have implemented in multiple utilities across the world. Here, primarily, we are talking about LiDAR and imagery, because these two components of the data enable us to build digital twins effectively. And they also help us to trace the fourth dimension that Voxel talked about, the change detection. If we have snapshots of data from previous periods, and we can compare that with the current period or any 2 points of time in the past to identify the changes. And the rest is all, computational power, storage power.
Bhoopathi, this is Dan. Your mic is going in and out ever so slightly. I suggest you might lean forward because it seems like maybe when you lean back a bit, your mic goes out a bit.
Okay, yeah, I'll be a bit loud and I'll lean forward. Can you hear me okay now?
Yes, that's good, thanks.
All right, thank you. So when it comes to LiDAR processing, we have come a long way in the last 15, 20 years, right? So LiDAR processing has been heavy in terms of data size, again, in terms of processing, computing power, it is heavy, but the automation has helped us to process the LiDAR data to a great extent without using any much of the human effort. So things like ground separation, identifying conductors, towers are pretty much automated now. So we have models to automatically trace ground and non-ground separation, identify conductors and towers and specific aspects of the assets as well. For example, pole assets, pole attachments, like pole transformers can be identified and classified automatically using the machine learning algorithms these days. The second thing is, once you have the imagery and the LiDAR, what we do is building up a 3D virtual model. There are existing platforms like SD that support tremendously to build 3D virtual models or digital twins. And then a lot of third-party tools coming up these days to that enable immersive 360-degree virtual panoramic views of the network that is like as good as a human going there and looking at 360 degrees. You can see digitally on the screen by collecting multiple imagery, 360-degree imagery and embedding into a panoramic view. So followed by that is the analysis part. This is where traditional tools and the emerging tools help us in terms of identifying the vegetation encroachments, any human created encroachments, road networks, water lines, buildings, etc. And also the traditional PLS-CAD modeling can be brought to the web page. So historically, PLS-CAD modeling has been exclusive to the line engineering group, people who have exclusive license to deal with the PLS-CAD data. Now, once the modeling is done, that PLS-CAD model's output can be brought into the web browser and made it accessible to vegetation managers or GIS managers or even environmental compliance groups. So this is what we have done in our solution by bringing the PLS-CAD outputs to the browser-based 3D virtualization platform, what we call digital twin of the utility network. On top of that, now we're talking about, we are so excited about asset identification, enumeration, detection, and condition assessment. So there are pockets of models, let's say unique models built for identifying specific assets, for example, insulators here, and even detecting if there is any damage to it. So things such as reading the text on the platform-based pad-mounted transformers or any kind of assets is something is a good possibility today, and we have implemented in our platform. So a quick list of the use cases that we have implemented recently for transmission network is identifying insulators, conductors, dampers, bird guards. So as you see the list here, in all these cases, it's mostly identification of them and then enumeration, how many of them are there, and then identifying the basic conditions. If there are visible cracks damages to it, those things can be identified. Similarly, in distribution network, you see a list of assets here, and their detection is possible.
Bhoopathi, I wonder if while you're trying to get that going, you could explain it. Oh, okay, it looks like you got it going. Yeah.
Yeah, I got it.
Is this the kind of environment that the end user or the client would be in when they're interacting with this digital twin?
Right. So it's a browser based. So I opened it in the morning, and I left it there, and then I opened multiple applications. So that's probably this session timed out. So I refreshed it. So this is how you you look at it. So it's all circuit based. You select a circuit that you wanna browse and analyze. All the circuits that are modeled are available here. When click on a circuit, what you see is a dashboard that you see. This is all configurable, where you see spans, poles, hazards, and number of grow-in, fall-in, encroachments. All these reports can be custom built, or you can just configure what reports you want to see and what data you want to see here. But the most interesting part is what we call the digital twin of the network, and various aspects of analyzing it, both from the chart point of perspective. You see the encroachment report that typically any vegetation manager want to see. So something that I want to highlight here is the volumetric component of the encroachment. What is the volume of the tree in cubic feet that is under encroachment? And we can see that, and you can sort it out. And then if you want to fly to a particular tree, the maximum volume that I need to cut, I can just go there. I can just click on that and fly to that particular part of the network. And here you see the vegetation encroachments. Let me switch on. This is the as-built condition. Let's say I want to see the max sag condition. So with the PLS-CAD modeling, when I get max sag condition, I can look at the max sag condition here. Yeah, this is when I see the max sag condition. The perspective changes. Let me switch on the LiDAR point cloud. Sorry. So you have max sag blowout condition, and for various situations we can see the encroachment. And here every encroachment point has been modeled here. So you have various aspects available in terms of the span, the grow in, fall in, what kind of encroachment it is. Then you can see the same thing for not only for vegetation, for building encroachments, railroads, water bodies, and various sorts of both man-made and also natural hindrances to the network. We also have asset analytics. Asset analytics is about identifying a particular defective assets, for example. Let's say, as I was talking about a model for detecting insulators and their defects here. So the way it works is that it categorizes and lists all the defective insulators. And when you click on a particular insulator, you can fly to it and then look at the defective part of it. For example, these are all the insulators that are defective. It's a porcelain. I click on one of them, I can fly to that particular part of the network. So it's relatively heavy data, but being optimized for delivery on the browser, as you see here. So I can identify the insulators that have a particular condition here. So here we're talking about insulator porcelain defective, and I can look at it, the imagery. So this is flashed here. So this is it's a UAV acquired imagery, processed and tagged to the network, and made it available for viewing and analysis. Similarly, we have other analytics such as pole lean. So the pole configuration has been analyzed and processed by algorithms to detect lean, and a report has been prepared here, and that is available for viewing as or you can just jump on a particular pole and identify that lean. So the reporting aspect is rich with all the data. You can export this data to Excel or PowerPoint, or simply if you want to see a digital twin alone, the digital twin part is purely a 3D virtual network that you can navigate to, and you have the snapshots available. If you want to go back, let's say previous year snapshot, or current year snapshot, and that will give you a change detection aspect. A subset of that is what we call audit. For example, before trimming, you have a snapshot, but after trimming the vegetation and you have a new snapshot, that would give you the change detection. So it will be useful for identifying or verifying the trimming jobs, the quality control aspect of it, and also to check if there is any new construction, new changes to the network. All those things can be identified in the audit process. This is possible when you have at least 2 snapshots of the data or more. So in every case, you have both power network, that is general standard condition, max sag condition, or blowout or max sway condition. You choose the particular assets that are that you want to see, insulators or shields, or leave them away. And you also can switch on LiDAR point cloud for improved visualization, or if you want to just quickly navigate without loading heavy data, you can do it without LiDAR data as well. So that in a summary is the solution. This is available both for transmission and also distribution. I have a distribution sample here, which is pretty much same, but only context is in a distribution. You have a different kind of attributes, different points of interest here, but the solution is same. The way it is rendered is same. So these are the vegetation encroachment blobs identified, pre-configured and loaded. You can switch that off and directly move on to the LiDAR data if it is of interest. Yeah, it's as you see, this is for the entire circuit level of LiDAR data loads into the browser as you start browsing for it. So each and every conductor is modeled, every asset is individually modeled, and the data is pulled out from the asset management systems here. So that is in a nutshell the summary. I would like to answer questions if you have any.
Yes, thanks, Bhoopathi. Are there any like clients that wouldn't mind being mentioned by name? Different utility firms, or?
Sure. Yep. Absolutely. So as I said, we've implemented this solution in Asia Pacific, Europe, and US. So here, my friend Craig is here. Craig and I worked on multiple projects together. We have acquired data for Southern California. Edison processed that, and we have implemented this solution for a few circuits. With Vegetation Management team at Southern California, Edison is quite familiar with our approach in terms of data acquisition, processing, and delivering it over the web as well.
Okay, is this a hosted service, like a Cyient host a digital twin for a client?
That's right. So this is a hosted service. We host it on our Cyient managed cloud, or some of our customers have their own cloud account. We can host it on their private cloud as well.
Oh, okay. Yeah, you segued into another question about what's the process, the workflow, like the client, a public utility district or a private electric utility. Are they providing you their planimetrics or their GIS data? And then do they go and get the aerial or ground-based imaging and LiDAR and provide that to you, or do you also do that as well?
We do that. Typically, we acquire, ground control points, and we set up the ground control points and acquire aerial imagery and LiDAR, oblique imagery for mapping these towers and capturing the insulators if required. And we get the asset data from the utility, from their asset management systems, and then configure it in our system. So in case the LiDAR data, aerial data is available, that can be configured too. But usually it's a fresh acquisition many times.
Okay. And then to get the resolution you need. And then on that note, well, because I'm actually wrestling with vegetation management proposals right now, what's the best option for that? I mean, vegetation management and distribution is that's a sticky situation. It's tough, tight tolerances. Is it ground-based LiDAR and imaging, or aerial LiDAR and imaging, or is it the combination of perhaps all four that's the optimal?
Yeah, I mean, it really depends on the situation, but we think as long as it is a drivable network, mobile mapping is a great solution, because mobile mapping gives much more perspective, access to the assets data. So, but for the inaccessible part of the network, of course, we either go for UAV or aerial. But as long as the network is accessible, we recommend taking mobile mapping data.
Okay, and then you're identifying and you are doing an inventory of everything down to the conductor, the insulators and the conditions on those. Is do you use like the the as-built if they exist, or is it using the image to identify the features and pertinences in their conditions?
We use the imagery to first identify and enumerate them in terms of the basic configuration. And then after that, we run this crack detection or damage detection algorithms to process them. Yeah,
well, I'll paraphrase a question. How automated is that? How much does it pick up automated, and how much do you have to go and do a human overview of the questionable ones?
Yep. So no AI is 100% accurate. So let me be clear on that. So AI accuracy depends on the kind of data, the volumes that you feed in. So typically it ranges from 70 to 80, 95% if you're really good at it. Okay. The aspect is the human aspect that we use to complement that gap. But again, depending on the use case, if it is just the detection, the accuracy is usually really high, goes up to 99%. But if you want to assess the condition, that's more subjective. That's where accuracies drop down.
Okay, and on the versioning, keeping this up to date, and you talked about you can go back through the snapshots, which is where you can come up with the trending and statistics, but well, it's not practical to kind of refly or redrive the entire network every time.
That's right.
Snapshots in sections, can they be in sections? Like if you have a 1 mile segment of the entire network that has recently been reflown, does that sort of identify when you go into the digital twin that there's versioning data for that area?
Exactly. So we don't need to acquire the entire network for sure. It's point by point. So location, you can acquire just 1 mile, and then that part of the network is available. We can clearly identify, flag where the history chronology is available, where it is not available.
Okay, great. Well, thank you. I hope you stick around for the roundtable at the end. Thanks for the insightful presentation.